So let's go through an example involving non-permissible values. You probably know that the log of a fraction can be rewritten as the log of the numerator, x minus 3, minus the log of the denominator, x minus 2. But if you graph this out, you'll actually find that the first equation has a solution, but the second one doesn't. And this is because you need to take into consideration that when you're logging a number, the number inside the log must be positive. If it's 0 or negative, the log of that number will not be defined. So you get the restriction that x minus 3 over x minus 2 must be greater than 0 for the first equation. And for the second equation you get x minus 3 is greater than 0, or x minus 2 must be greater than 0, which leads to x is greater than 3 and x is greater than 2. In this case, you take the more limiting restriction, so x is greater than 3. In this case, you might want to make a number line because it's hard to see which values of x work and which ones don't. So you could graph this out, or you could just put in the values of x that would give you an asymptote if you rewrote this as y equals x minus 2 over x minus 3. So asymptotes or zeros would be at x equals to 2 and x equals to 3. So if you take, now you can just use test points in any of these locations. So if you take a test point at x is less than 2, let's try 0. 0 minus 3 is negative 3, 0 minus 2 is negative 2, negative 3 over 2 is a positive number. If you try test point at 2.5, 2.5 minus 3 is negative 0.5, 2.5 minus 2 is positive 0.5, a negative over a positive is a negative. And a number greater than 3. Let's try 4. 4 minus 3 is 1, 4 minus 2 is 2, which will give you a positive number, because positive over positive is a positive. So you can see that numbers less than x values less than 2 and x values greater than 3 will work. So your restriction for this equation is x is less than 2 and x is greater than 3. Notice how all values of x less than 2 work in this equation, but they don't in this equation. So if you actually try to solve this equation, you'll get log, you can take 10 to the power of both sides, so that'll give you 10 to the power of log x minus 3 over x minus 2 equals 10 to the power of 2, which just equals, scroll down a bit, x minus 3 over x minus 2 equals 100. Therefore, x minus 3 if you rearrange this, you get Alright, so you get 197 over 99, which is about, let's check, 197 divided by 99, 1.99 practically, or, oops, x equals 1.99. So if you look at our restrictions above, x equals 1.99. You'll see that x equals 1.99 fits the restrictions of the first equation because any value of x works as long as it's either greater than 3 or less than 2, and 1.99 is less than 2. But for the second equation, where the restriction is just x is greater than 3, 1.99 is not greater than 3. So although it works in the first equation, and the second equation is practically the same as the first equation, the second equation has this restriction that doesn't allow this to work. It's called a non-permissible value. So yeah, that's why the first equation has a solution and the second one doesn't, although they are very similar. Thank you for watching.